Good evening everyone, I'm Paolo Barabanti, I'm a researcher at INVALSI. So, in this parallel session, we are talking about two main topics mixed together: characteristics and peculiarity of students, and learning environments and student outcomes. As we're going to have 4 papers rather than 5, so lucky speakers, I ask to all speakers to squeeze your speech for a maximum of 20 minutes, okay? After 15 minutes, I tell you, you still have 5 minutes. At the end of all speeches, we're going to have a moment for questions and just to discuss together about these papers. So, we can start now with the first paper titled Measuring and Explaining School Performance, Evidence on School Value-Added Models by Soncin and Chiara, Masci, and I think also Tommaso Agasisti, but today, Soncin, the floor is yours, only yours.
So, good afternoon everyone. I am Soncin, I'm from Politecnico di Milano. I'm going to present this, let's say, working paper that is about indeed school value added. This is a joint work with Chiara Masci that is here as well, and Tommaso Agasisti. So basically the reason why we are focusing on school value added is because as most of us know, and also INVALSI, compute value added for schools, this is a measure that is increasingly used for school accountability. Especially in the Anglo-Saxon context, so in the USA and in the UK, it has been used also for high-stakes reasons and to support school choice. Despite the, let's say, broad use of this kind of measures, there is still an open debate about the stability of these measures, given that especially over time we notice that there is a low correlation of school value-added measures, so it's highly dependent on the specific cohort under investigation, and also about which is the best methodological approach to be used to measure the school value-added. There is a kind of less debated issue that is related to which are the variables that should be included in school value-added models. Because indeed, depending on the variables that we include to estimate the school value-added, we do have different measures. So the way in which we, let's say, define the school value-added is what the school add to the student performance net of any exogenous factors. So indeed, which are these exogenous factors is also related to how we actually get that value-added measure. The other question is related to which are the factors that can help us to explain why we get this variability in school value-added. So can we explain the school value-added measures? This is indeed the research question that we are addressing in this paper, that is related to what are the factors that can support the explanation of the variability in school value added. In this respect, we define school value added as the difference between the test performance of the student in a specific school and the average performance of students in schools populated with similar characteristics. In terms of the literature about this topic, again, we know that regardless the specific methodological approach that have been used to estimate the school value added, actually we know that there is not much difference in the school value added measures, while the open issue again is more related to the low stability of these kinds of measures over time. There is a smaller part of the literature that also addresses the relevance of the variable selection that again affects the way in which school value-added measures are estimated, in the sense that depending on which are the variables that we are including in the model to estimate school value-added, we can get a kind of gross versus net school value added measure. Also part of the literature addressed the fact of which are the motivations behind a certain positive or negative school value added. And the studies in this respect stress the fact that the most important factors are, of course, related to the teaching practices and the organizational factors. Well, in this respect, in the literature, we do have some studies that try to explain why a school have a negative or a positive value added, but they are usually small-scale sample, like single schools that decide to go deeper into why they get a certain value added. And the debate on this topic is very much practitioner-oriented, so we decided to address this topic also because of our discussion with school principals that want to understand why they get a certain school value added measure. But we think that this is relevant also for the academic literature in order to, yes, contribute in general to the debate on school value added. Well, the way in which we are addressing the fact of first estimating and then explaining the school value added is by using a two-step methodology. In the first step, we use a three-level model in which we can consider students I nested into schools J, again nested into regions W. This is a linear mixed effect model, so basically a linear multi-level model in which the vector of the school value added is defined as that BWJ, JW, sorry. Basically, that is the vector of the school value added net of any regional effect. And the reason why we decided to use also as a level within our model the regional level is that from previous research we know that in Italy there is a lot of heterogeneity at territorial level, a lot of structural differences across regions, and we wanted to estimate the school value added net of structural differences across regions. So this is the reasons why we decided to add an additional layer, that is the regional level of grouping, so that that school value added is net of any structural difference across regions. Then, taking that vector of school value added measures, we add a second step. The second step is the one represented here, so basically we explain the school value added by using an additional set of covariates that are somehow endogenous to the school. So we use the exogenous variables like the characteristics of the students and of the school in general to estimate the school value added. And then we use endogenous variable more related to teachers, funding, use of funding and so on to explain that specific school value added. We actually do this by using an ordinary least square model and also a random forest in order to somehow release the assumption of linearity and see what changes. So our data. To estimate the school value added, we basically use the INVALSI data. That means that our measure of outcome is the student outcome at grade 8 in mathematics, and the reason why we focus on mathematics is that we know that usually the school value added for mathematics is larger than for reading, so the school effect in this respect is larger, and we focus on that. While for covariates, we do use the rich information that INVALSI collect about the previous test score of the student when he or she was in grade 5. And then information about, yes, whether the student has a, let's say, a high or low socioeconomic status by means of the SES index, whether the student is a female or male, late enrolled student, foreign student, whether they attend kindergarten and so on. And then we do have additional class level covariates that are mainly aggregated from the student level, plus school level covariates that are again mainly aggregated from the student level. We use this information that are somehow again exogenous to the school, like the school composition, the student characteristics and so on, in the first step. That is the one in which we compute the school value added. Then, in the second step, we want to explain that school value added measure. And the way in which we are doing this is by matching INVALSI data with additional novel data provided by the Ministry of Education. So we had the chance to match the two. In this second step, our outcome measure, our dependent variable, is the school value added. And we explain that school value added by using information on the school funding, so basically the way in which the school used the money and the origin of that money. Then we do have information about teachers, in particular the teacher composition in terms of experience in the specific school. We do have information about days of sick leave in the year, about the age of the teachers, about the number of tenured and non-tenured teachers. Then we do have additional information about the family involvement. Unfortunately, this variable is a dummy, so basically we just know whether or not the school organized, let's say, events, projects with the families, and so on. So what we can see is that actually the schools tend to involve the families quite a lot, so the variables are quite close to 1 as a mean. In terms of projects with the families, this is basically the 70% of the schools do this kind of projects. That is, let's say, the lowest values among the 4. Then we also created some variables related to the school and class composition. So here the idea is that the school principal, the school decide how to create the different classes. The principle that the school principal should have is to maximize the heterogeneity within classes. So what we are measuring here is creating some variables that are related to how the different classes were composed. That means that we computed the within school, between classes variability in the school and in the average student score, in the socioeconomic status, and in the percentage of foreign students, in order to assess whether, let's say, the different classes were balanced or not. Then, about the school principal, we do have information about the years of experience in the specific school and overall in the educational system. And finally, we are also controlling for the average school performance in the INVALSI score. As a result, this is the result from the step 1 of the analysis. So, again, the output is the student test score in grade 8. This analysis is run at student level, so here we do have more than 360,000 observations. Again, we are considering, let's say, the more exogenous factors here, and we see that the variable that is most positively associated with the outcome is the previous test score of the student. Then we do have the socioeconomic status of the students that is positively associated with the outcome. And we do have additional information, like the fact that there is a negative association between the fact that the student is a foreign student and the outcome, the fact that the student is a later enrolled or female, then positive association with the fact that the student attend the kindergarten, and then other, let's say, results related to the class level variables and the school level variables. So basically, this is the first step in which we compute the school value added. How this school value added measure is distributed. So what you see here in the left-hand side is the distribution of the school value added. As I mentioned in the methodology, we are computing the school value added net of any regional differences. So basically we also have the regional value added. And that regional value added is distributed, as you can see, in the right-hand side. That distribution is kind of more skewed towards the right. And is basically what net of any other factor the region adds or not to student achievement. What we can get from multi-level models is also the percentage of variation captured by random effects. What we see here is that the percentage of residual variation at regional level is about 10%, that is close to the 10% at school level. So basically what we can observe is that the percentage of unexplained variation at regional level is at least comparable to the one at school level. That means that, as we all know, there is a lot of territorial variation in our country. But in this model, we are reasoning net of that structural differences. The remaining 80%, more or less, is variability unexplained at student level. Now, in our second step, we use as an output the school value added measure. Here, our model is run at school level, so we do have a number of observations that is nearly 3,800 schools. What we see is that having as an output the school value added, the more the percentage of expenditure in teacher salary, the more the school value added. While for the percentage of funding received by the state, this has a negative correlation that can be explained by the fact that, for example, schools that have more troubles or those that are in the south can receive additional funding. Interestingly, about the school characteristics, the years of experience in the school of the school principal are positively related to the school value added. That means that there is a kind of matching effect, positive matching effect between the school principal in the school and the school value added. Then, the more the percentage of tenured teachers that stay in the school since less than 1 or 2 or 3 years, the higher the school value added. But these are not necessarily young teachers, because when we look at the age, we actually see again a positive correlation with the school value added. Also, we notice that in terms of days of sick leave, this is negatively correlated, so the more the teachers are absent and the lower is the school value added. We also see an effect related to the number of tenured and non-tenured teachers, because the first factor is positively related to the school value added, the second one is negatively related. So also, let's say the stability of the teaching body is relevant to explain the school value added. Additionally, the between class variability score is negatively related. That means that if the classes are unbalanced in terms of student score, then the school value added is lower. As additional analysis, we also run a random forest, again to release this assumption of linearity among the variables. And what we see as the most important factor is actually that the average school score in the INVALSI test is by far the most relevant factor that is not represented here, just to visualize also all the other elements. In addition to that, we get that the class composition, so basically again the variability between classes within school in the student score and the socioeconomic status are a relevant factor to explain the variability in the school value added. Then again, we found factors related to the teaching body, so the years of experience in the school, and again the number of non-tenured teachers is very relevant to explain the school value added. By means of this kind of analysis, we can also assess more graphically the relationship between the school value added that is on the y-axis and the specific variable that we are visualizing that is on the x-axis. what we see is that for the number of non-tenured teachers, there is a kind of very sharp inclination of the curve. So the more the non-tenured teacher, the lower is the school value added, while for the number of days of sick leave of teachers in a year, what we get is that when we have a number of sick leave that is around 5, actually there is no negative effect. But then the school value added decreases very sharply. So that's also very relevant factors. We can also visualize the factors together. So here basically we are seeing the two variables, the same two variables, so the number of days of sick leave and the number of non-tenured teachers, and we see that when they are, let's say, the lowest, the school value added is the highest. And finally, this is also representation in the between classes variability in the socioeconomic status. So to go to the conclusions, we think that to properly estimate the school value added of schools, a more focused reflection on which are the variables that should be used in its estimation and in its explanation is needed. And we want to contribute on this debate both on a practitioner side and on more academic side. We see that the variables that are the most important to explain the variability in the school value added are those that are related to the teachers. So again, this is a kind of claim to the need to gain more data about teachers. From a policy perspective, this is needed on a large scale because as far as we know, we do have very different examples that are though on a small scale. And there is also the need to explain more clearly the variables that are included in the say, computation of the school effect and those that can be used in its explanation. What we want to do in the future is to dig a little bit more into these aspects, also by comparing those schools that do have a low and a high school value added in order to see whether there are differences in the factors that can help us in explaining what we see. And that's it. Thank you.